All right, welcome back. We're doing Chapter 3, Section 4, Linear Programming. This is the fourth example that I'm going to record. And between now and next week, I might actually record a couple more. So stay tuned. I'll let you know. But we'll see if 4 is going to do it. And of course, we'll do more of these in class. Let's get started. We have a cafe. They sell cold sandwiches and hot entrees. Okay, so an entree would be like, mac and cheese or something like that, right? The range of items sold is shown in the table. The cafe has never sold more than a total of 125 sandwiches and entrees in one day. So that's a way of saying they've never had more than 125 patrons. People have come in and ordered something, all right? Now, talking about that and looking at all of the examples that we've done, the ones that we've done in class, live, and also the ones that I've recorded. I'm hoping that some of you have caught on to something. It's kind of hidden, and it actually means that these problems are actually easier than what they would seem. In other words, there's something different about these problems. They're specially chosen in a way that it makes it easier than what a real life problem would be. So I'll see if anyone can catch on to that, and we'll see what if anyone can come up with that. All right. So have that in the back of your mind while we're talking about this. So this cafe apparently just sells sandwiches and entrees, nothing else. If the cafe makes a profit of 75 cents on each sandwich and $1 on each entree, how many of each item should they sell to maximize the cafe's profit? So we have some information here. The number of cold sandwiches, it's the smallest that they've ever sold. The least amount they've ever sold has been 60. The most has been 80. For the hot entrees, they've never sold less than 40, and they've never sold more than 60. Okay, that's going to be information for our constraints. First, let's define the variables. So we're going to let, one more time, x and y. We're going to let x represent the number of cold sandwiches, and we're going to let y represent the number of hot entrees. Put the little accent right there. All right, let's talk about the constraints. Now the table shows me the constraint for the cold sandwiches. The number of cold sandwiches is going to be x, so x is going to be between 60 and 80. So let's write that down. So x is going to be between 60 and 80. And we say 60 is less than x is less than 80. Or you could write x is going to be greater than or equal to 60, because that's what that means. And x is going to be less than or equal to 80. We mentioned in the previous video, I don't care which one that you do with that. When I graph these, sometimes it's easier if I graph it by hand this way, but Desmos will do both, okay? Probably easier if I do this, but if you understand what this means, you can still graph it that way. And I'm going to go ahead and do it. I know I usually graph when I get all the constraints done, but I want to talk about this while I have it. So x is greater than or equal to 60. The boundary line is x equals 60, and that is right here. And I'm going to graph on this side of it. I'm just making some marks here to tell me which side I want to be on. Eventually, when I get all my constraints done, I'll know how to shade the whole thing. X is less than or equal to 80. Here's 60, here's 70, here's 80. So that's kind of a very small, narrow range that I have there. So it's going to be somewhere between this. It's going to tell me how many cold sandwiches I have. All right, let's figure out the hot sandwich or the hot entrees. 40 is the minimum, 60 is the maximum. So y is going to be between 40 and 60. Or again, you can do y is greater than or equal to 40 and y is less than or equal to 60. So my boundary line is y equals 40. That's right here. And I'm going to have more than that. And my boundary line is y equals 60, so that's going to be right here. And I'm going to be less than that. So in this box right here, in this rectangle, which happens to be a square, but don't worry about that. In this rectangle is going to be how many sandwiches, cold sandwiches, and how many entrees we're going to make. Except we have one more constraint. It turns out that they've never sold more than a total of 125 sandwiches and entrees, which again, that basically kind of means that's how many customers that they've had. So my last one is x plus y is less than or equal to 125. So now we need to figure this one out. We need to graph it. If I let x equal 0, I get y equal 125. Here's 100, here's one, yeah, I'm going by tens, right? Yep. So here's 110, here's 120, 125 is about right there. I don't know if you guys can see that, but yeah, when I printed that, my lines are in there, they're just really, really faint. And then if I let y equal 0, I still get x equals 125. So basically that's saying everyone is going to eat a hot entree, or everyone is going to eat a cold sandwich, if none of the other constraints are going to take place. So now let's do this right here. And I'm just double checking something. Yeah, sorry, I was double checking to make sure I had things lined up right. Okay, so now that's going to come down this way. And it looks like my feasible region is this part right here. Okay, so it looks like I've got a pentagon, 5 sides with 5 vertices. Right here, this is going to be 60-40. So 60 sandwiches, 40 entrees. That's a possibility. And that's the minimums, the minimum number of sandwiches and the minimum number of entrees, all right? Which is still going to be 60 plus 40 is 100, which is less than 125. I could also have 60 of each. So that would be the minimum number of sandwiches, but the maximum number of entrees, which is still going to be less than 125, because 60 plus 60 is 120. Right here, I'm going to get, find a place to write it because I don't have much room here. This is going to be the maximum number of sandwiches, which is 80, and the minimum number of entrees, which is 40. Now, all of these, that one's right here, all of these are on horizontal or vertical lines. I don't need to do substitution or elimination to figure them out, okay? Those are obvious. But now I got these two. This one appears to be x equals 80, because this is my vertical line where x equals 80, so that makes sense. But I got to kind of figure out what my y value is, okay? So if I kind of come over a little bit, I don't know, it's kind of hard to tell. So I'm going to guess and say maybe, I don't know, it looks like this is 40, this is 50, so it looks a little bit more than halfway, but let's just guess and say it's halfway. Let's just say 45. And this one, which is right here, my y value is going to be 60, but it's kind of hard to figure out where my x value is. And again, here's 60, here's 70, so it looks like it's going to be halfway. Maybe not, I don't know, maybe I drew the line in the wrong place or something, okay? I am using a marker, and it is, you know, maybe I don't have it exactly, but I think my guess is going to be, let's say 65, 60. Now, I don't know if these two are true, so I'm going to use substitution to figure it out. I need to find out where this line which is y equals 60, and this line, which is x plus y equals 125, intersect. And then I need to find out where this line, this diagonal line, which is still that, and this line, which is x equals 80, are going to intersect. So my substitution should be pretty simple because I am using vertical lines. All right, so my line that has my slope of -1 is x plus y equals 125. I'm going to test that one with this one, y equals 60. So this should be pretty simple. I get x plus 60 equals 125, subtract 60, and I get x equals 65. And I think that that's what I said. So yeah, that's my good guess. So I got 65, 60. So that one works. My other one, I still got x plus y equals 125, but now I'm going to test it with x equals 80. So I have 80 plus y equals 125. Subtracting 80 gives me y equals 45. So 80, 45 is the other vertex, 80, 45. So even though it looks like it's a little high, my picture's off a little bit. If I, say for example, if I said, well, it looks more like it's 80, 47, all right? Then I would actually test it and say, no, it wasn't supposed to be 47, it was supposed to be 45. So by using substitution or elimination, this one lended itself for substitution, but by using substitution or elimination, I was able to accurately determine where the two lines intersect and what that vertex is. So you'll have to include that into your project. Now, the last part. What is the profit? Let's go back to the first sheet. They make 75 cents for each cold sandwich and $1 for each entree. So that is 0.75 times each cold sandwich plus 1 times each entree. And you probably don't need to put the 1 in there, okay? But I show the stuff that's hidden. So here's my points that I need for my table. Number of cold sandwiches, number of entrees, and my profit function. So I have 60, 40. I have 60, 60. I know it's hard to get everything in the same screen, isn't it? I have 80, 40. 65, 60. And finally right here I've got 80, 45. Draw my lines in here to make it a little bit easier to understand. Alright, so I got 0.75 times 60, that's my x, plus 1 times 40. So that's, I'm going to cheat, I'm going to use my calculator. 0.75 times 60, should be 45, plus 40. They're going to make a profit of $85 if we do it that way. 0.75 times 60 plus 1 times 60. I'm guessing this is going to be 105. 0.75 times 60 plus 60. That's going to give a profit of 105. We're assuming this is a small company, a small restaurant. 0.75 times 80 plus 1 times 40. That's only $100. So actually you're better off with this instead of this by $5. 0.75 times 65 plus 1 times 60. That is $108.75. And finally, 0.75 cents for 80 sandwiches, and $1 for 45 sandwiches. That's going to give $105 again, just like that one. So, to maximize their profit, this cafe needs to sell right here 65 cold sandwiches and 60 hot entrees. Move that up so you can see that. I apologize for that. All right, I'll take pictures of everything so you can look at it on your own time. Like I said, I'll see if I will, if I need to make more videos, I will. I just want to be clear about the steps, since I got a little time left in this one. You're going to start by identifying and defining your variables. What is it you're asked to find? That'll always come from, like the question. This one says, how many of each? That's cold and hot food. You're going to come up with your constraints based upon the information. You're going to graph it, and you're going to figure out what the vertices are. The vertices that are not obvious, you're going to use substitution or elimination to determine. No guessing. You need to show this step. And finally, after you find your vertices, the maximum profit, in this case profit, is going to be at one of those vertices. It's not going to be in the middle of the feasible region someplace. It's going to be at the extremes. So the extremes represent, or sorry, the extremes are the vertices. So then I just determine my profit formula, figure out how much money you're going to make. And the best case for this company, this cafe, 65 sandwiches, 60 hot entrees. That's 125 meals total, which is under the constraint, and it's within the other boundaries for the constraint. All right, good luck.